We are in grade 11, mathematics. The topic is mensuration. So basically, we are going to look at um, questions that usually come up, and these questions are going to actually solidify our foundation in this concept. Now, let's say you have a shape like this one. Let's say you have a shape like this one. It's a semicircle. Okay? It's a semicircle. All right. Let's say it looks like this. This is shaded. Okay? It's shaded. Now, we have from here to here is 12 centimeters. And from here to here also, we still have 12 centimeters. Now, this shape is made by removing a small semicircle from a large semicircle. It's a shape which was made by removing a small semicircle, this part. It was removed from a large semicircle. So we have this shaded shape. Okay? Now, the question is calculate the shaded area or the area of the shape. There was a large semicircle. Then we removed this small semicircle. Then we had this shape. So now you are asked to calculate the area of this shape. Okay? Now, if we are talking about a semicircle, if we are talking about a semicircle here, a semicircle, that means we are talking about half a circle. Half a circle. And when we talk of half a circle, we are talking about part of a circle. And when we talk of part of a circle, we are actually talking about a sector. All right? We are talking about a sector. Now, we in grade 10 we did talk about the area of a sector or sector area. Sector area. And the sector area equals to angle theta over 360 degrees, all right? Then multiply that by the area of a circle, which is pi r squared. So this fraction of a circle, it's actually the angle that subtend to form the sector. You will have to understand that a sector is made up of two radii, 1 and 2. 1 and 2. 2 radii plus an arc. This is an arc here. Okay? So now this is the center of our circle. And the angle theta is the angle between the two radii, which is this angle. Let's say we have this radii here. Okay? So there is this angle here. This angle here is the angle theta. So in our case here, to find the area of this shape, being the shaded area, we must understand that it is going to be area of large sector area minus small sector area. Good. Now, if then this will give us the shaded area. This must give us the shaded area or area of the shape. Okay? This must give us the shaded area. Okay? Now, now you can see that the sector here will have this area. Okay? The sector there will have this area. What will differ is, but now because the two, this small sector, this one has its center here. All right, it has its center there. So its radius here will be 6 centimeters. Okay, and 6 centimeters to make the 12 here, because this 12 here is its diameter. So the diameter of the larger sector is 24 centimeters, and the diameter of the small sector is 12 centimeters. Now that means the radius of the larger sector is going to be 12, while the radius of the small sector is going to be 6 centimeters. That's the only difference. But the angle here is the same as the angle here. Okay? Yes. Now you understand that this is the angle of a straight line here. It's 180 degrees. Okay? So our theta is 180 degrees. Okay? Now let's see for this large sector area, we are going to have theta over 360 degrees. All right? Theta over 360 degrees. Now we are going to multiply this by pi radius squared, and the radius here should be radius of the large sector. Okay, now theta here should be theta of the large sector. Okay, now we are going to subtract theta of the small sector divided by 360 degrees times pi radius of the small sector squared. Then that will give us area of the shape. Okay, now let's see what we can do here. Let's see what we can do here. Let's substitute the numbers. So the theta here is 180 degrees over 360 degrees times pi. Our pi is 3.142 times radius. That radius, the radius of the large sector here is 12. So we are going to say 12 centimeters squared. Okay. Now here we are going to subtract theta of the small sector. Theta of the small sector is still 180. No, 180 degrees over 360 degrees times pi times radius, and the radius of that small sector is 6 centimeters. So we square this. All right. Now, what we are going to do now is to work out the numbers. So we are going to multiply 180 degrees over 360 degrees is actually 0.5. It's half. Okay. So we are going to say, let me start with work out this. Let's work out this. I started with 12 squared. 12 squared is 144. Then time is 3.142. 142 times 0.5, right? We get this becomes 226.224 centimeters squared. So we are going to subtract this one, this one. It's also 0.5 here, right? Because this is half. Then times pi times 6 squared. Now, work it out. 6 squared, that's 36. I multiply that by 3.142, and I multiply that by half. We get 56.556 centimeters squared. Now this becomes the difference is what is the difference here? Hmm? What is the difference here? The difference here is 169.668 centimeters squared. And now this this is actually a shaded area. This is actually the shaded area here. Now, mensuration is one of the topics that really that will require your being creative and innovative. That means you need to have uh, imaginations when you are dealing with this mensuration. When you look at this question here, they gave you this shape. They told you that it was formed by removing the small sector from the large sector here. Removing the small sector from the large sector here. That removing tells you that if they want you to find the area, okay, of the shaded part here, that means you will find the area of the large sector and remove the area of the small sector. Like they are saying, removing the small sector from the large sector. Even the area that will be left will be the difference between the areas of the two sectors. That is why we said large sector area minus small sector area will give us the shaded area. That is very important. So if you can't be focused, it won't be easy for you to actually envision this and be creative enough and think of the relevant formulae and apply and get to the answer. It's not easy actually. It's just about your mental stability, and then you just build up some frames in your mind and then put them on the paper and present your solution. All right, see if we can work on this one. There is another question that is of interest. um, it's the same concept but in a different presentation. You may have a semicircle like this. You may have a semicircle like this, okay? And this semicircle, yeah. Now, you have a circle within the semicircle. A circle inscribed in here. It's a circle, okay? Then they shade here. Hmm? They shade here. Oh, I love mathematics, right? Now, they say, okay, from here to here is 12 centimeters. No problem. Okay? Now, this would be A, this would be B. Now, they say the largest possible circle is thrown inside a semicircle as shown in the diagram. This circle is thrown within a semicircle as shown in the diagram. And then the distance AB is 12 centimeters. This is the distance, all right? Then uh, question A here says you should find um, uh, you should find the shaded area. Find the shaded area. And question B here says find the perimeter of the shaded area. All right, find the perimeter. Find the perimeter of the shaded area. Find the perimeter of the shaded area. All right. Okay. Now let's see what we can do. Let's see what we can do here. Let's see what we can do. Let's see what we can do here. Here, let's look at A. Let's look at A. Okay. Now, what has to be looked at here? It's very simple. Very simple indeed. Shaded area. It's this one. This one. But this shaded area, when you look at this shaded area, is the same as this area here. They are the same. Okay. So what we can do, because there is this circle and there is this semicircle and there is this shape here. This shape looks like this. This shape looks like this now. This shape. It looks like this. Okay? If you were to try to find a formula with which you can find the area of this shape, it's impossible. There is no formula. Because this shape, it's not a regular shape. Okay? Now, um, we need to use the regular shapes that we are given. And the two regular shapes that we have is the semicircle and the circle. So what we can do here, we can find the area of this semicircle because there is a formula for that. And we can find the area of this circle because there is a formula for that. Okay? What are we going to do with the areas? We will find their difference. We will find their difference. When we find their difference, then we will have the area of this semicircle minus the area of this circle. Then we will be having uh, the area, this one, this plus this one here, this one. Okay, okay, this plus this one. If we find the area of this semicircle and the area of the circle, and then we subtract the area of the circle from the area of the semicircle, we will have the shaded area here. Now, to get to this one, this which the examiner wants, then we will just divide by 2 because this region is the same as this one. So we just divide it by 2. Okay? So you can see that before I do anything, I try to find the inside of the information and find a trend or a direction or a footprint I'm going to follow. You don't just go and answer a mathematics questions without the analysis. Now, we are saying shaded area. shaded area here will be equal to sector area minus circle area. A semicircle is a sector anyway. Okay? Then we divide everything. We divide everything. We divide everything by 2. Yes, that is it. That's the analysis we have made. So now let's see what we can do. This says we are going to say sector area will be theta over 360. That's the formula. Time is pi r squared. Okay? Then we are going to subtract the circle area. Circle area is going to be what? It's going to be pi r squared. Then we are going to divide this by 2. Now we are left with substitution. We are going to substitute real numbers now. Angle theta here, the angle here, it's 180 degrees. All right, so we are going to have 180 degrees divided by 360 degrees multiplied by 3.142, okay, multiplied by r squared. So the radius of that sector will be 6 because the diameter is 12. Then we are going to subtract um, um, uh, the area of a circle, which is pi times I. The radius of this circle, if you look at this, let's go this way. That is the diameter. The diameter is 6, okay? Because this is the radius. It's equal to this radius here, okay? So if this is 6, this is 6. But we want not the diameter, but the radius. That means the radius will be 3 to make the 6. Now, we are going to have 3 centimeters, and we square that, okay? Now, what are we going to have? We are going to have 0.5 times 3.142 times 36 centimeters squared. So what we have? Work it out. Work it out. So 0.5 multiplied by 3.142 multiplied by 36 centimeters. That is going to give us 56.556. Then we are still going to subtract this one. 3 squared is 9, so we have 3.142 times 9. That is 28.278. Now, the difference here is how much? The difference is 28 point 28.278. But remember, we still have to divide the whole thing by 2. We still have to divide the whole thing by 2. So this is going to give us what? We divide this by 2 and we get how much? 14.139 is the answer. The answer is 14.139 centimeters squared. All right. So that is the area, the shaded area here. This area here. Okay, that is it. So that is it. Okay, look at the systematic approach here. Look at the systematic approach here. We did what we ought to do, right? So we did what we ought to do. We used our mind to actually frame our approach. We framed it mentally, and then we put it on the paper. You can't do anything in mathematics without the ability to actually mentally frame your approach. We started there. Creative thinking. Creative thinking. All right? Let's look at B. Let's look at B. This B wants us to find the perimeter of the shaded area. So perimeter would be the distance around this shape. The distance around this shape. So you will have to understand that this shape here is made up of uh, the sector here, huh? The arc, not the sector. This arc, okay, it's made up of this arc here and this radius here, okay, and then this arc here, arc 2, arc 1, okay. Now perimeter. Look at this, my friend. Perimeter here will be equal to arc 1, length of arc 1 length plus radius, which is r, plus arc 2 length. Can't you see? Can't you see? Now, this becomes interesting now. This becomes interesting now. We are going to have this. We are going to have this. Uh, we are going to say, okay, now let's see what we have here. Arc length, remember, arc length is actually uh, uh, a fraction of the circumference. So that's where we said it's theta over 360 degrees times the circumference. Circumference can be 2 pi radius. Then we are going to add the radius and add another pi theta over 360 degrees times 2 pi radius. This is actually our footprint. Now, let's see now. So the theta there, we are looking at this, and then this is actually from this. It's from this. What do we call this? The semicircle. So we are only looking at this portion here, arc. So we are going to use theta here, which is 90 degrees. So we're going to be 90 degrees over 360 degrees times 2 times 3.142. 3.142, okay, times radius. Radius is what? Radius is this one, which is 6 centimeters. Then we are going to say plus radius is 6, okay, this one. Then plus theta, we are looking at this, but theta is here. Now for that one, it's a semicircle. When you look at this circle, we are looking at the arc of this semicircle here, whose theta is 180 degrees. time is 2 pi. Pi is 360, 3.142 times r. The radius of that circle is 3 centimeters. So we're going to square this. I'm sorry. I have to squeeze here a little bit, right? Now let's follow. Let me just go here. Put my equal sign here so we have enough space. Now this is going to be 1/4 here, 0.25. Okay, 0.25. We multiply it through. There is something here. There is no square here. Okay, there is no square here. This is not the area, but just the circumference, no square. Now, what we have is this. We are going to work out this. We're going to work out this. Work it out. 0.25 multiplied by 2 multiplied by what? 3.142 multiplied by 6. So this is going to be 9.426. This is going to be 9.426 here. Centimeters plus 6 centimeters plus. What do we have here? That is half 0.5, okay? 0.5 times 2 times 3.142 times 3. That is going to be 9.426. 9.426. It's amazing, isn't it? It's 9.426. 9.426. Now, what we need to see here is this. We added this two thing. We get 24. We get 24.852 centimeters. This is the perimeter. Okay? All right. Now we did look at how to. We have applied two concepts here. We just applied the issue of the sector area, and we applied the issue of the arc length, incorporating them together to solve real life problems. All right. Now that's what basically mensuration is all about. I did think of doing these two problems just to give you a glimpse of what you need to expect as the questions. Okay, examiners questions. That's how they are going to ask you. Okay, so take care.